Hello, welcome students to my next video on the sensitivity analysis of the LPP. In this video, we are talking about the effect of the change in the vector B. Here, B means the right hand side of the constraints. That's quite obvious that this is the condition for the optimality of the any LPP for the maximization problem, and this is the general overview of the simplex table are there. Here is the row of the Zj minus Cj. Here is the total number of the variables are there. This is the basic variables. These are the columns which are computed with the help of the B inverse Aj, and this is the condition for the feasibility, that is B inverse B. Capital B is called as the basic matrix B. So myself, Harish Garg, I'm working here in the School of Mathematics, TIT Patiala, and you can contact me on my email IDs this and this respectively. Now very quickly, I just recall what is the sensitivity analysis that I discussed in my last video lecture also. So in general, this is the any LPP problem, that is maximization. Z is Cx, where C is the cost vector, X is the variable, A is the matrix of the m cross n, X is the vector, column vector, B is the right hand side, and X is the non-negativity condition is there. Now in this video, I am talking about the effect of this B onto the optimality conditions. Means what will happen if I replace the value of B with the new value of the constraint, then right hand side of the constraint, then what will be the impact on the optimal solution of the LPP. So that's why I'm just saying that this is the impact of the change in the right hand side of the optimality. So now I just remember students, before listening this video, I just hope that you may know about the basic features of this vector B. What is the speciality of this vector B and what it signifies that. For any LPP problem, either is a maximization or the minimization, that is the same problem, there is no worry about that. So this right hand side B is it should be the positive. First thing is that. Why? If it is a negative, then it doesn't tell us about the feasible solution. So if B is negative, then it means the infeasible solution is there if you are unable to compute into the positive sign by simply multiply with the negative sign on both B. Here B represents the feasibility. Remember students, this is represent the feasibility, not about the optimality. Remember, when we are talking about the optimality, we are talking about the Zj minus Cj, whether it's a greater than equal to 0 for the maximization problem and less than equal to 0 for the minimization problem. But here this B represents only the feasibility conditions B, and the change in the value of B rely on the feasibility conditions only. So we are not talking about the optimality conditions. Remember, whenever we are talking about the change in the right hand side of B, we are talking about the feasibility. We are not focused on the optimality condition. Here in my last video, I talking about the impact of the C. So here C is depending on the objective function. So this C is rely on the optimality conditions. So in this video, we are talking about the feasibility only. Remember the word feasibility. So what is the way? I just summarize the procedure in the basic 3 steps are there. If you follow these 3 steps, you are always able to solve this problem within a fraction of seconds are there. What is the first step is that you just calculate the B inverse firstly. The only rule, and there is no need to calculate it once you know the optimal table of the simplex method. This is the optimal table of the simplex method. Then you can easily write the value of the B inverse. There is no problem about that. And then calculate the B inverse B. Here you know the B inverse from this side. What is the B? B is nothing but the right hand side of the vector B. Okay, of the constraints. So then it is also known to you. If you multiply them, then you will get a m cross 1 column vector B. And if all the elements of this matrix are greater than 0 for all the elements, then the solution remains feasible as well as the optimal. That's the only condition. And if at least one of the element is less than 0, it means feasibility is disturbed. So if feasibility is disturbed, then you only use the Dual-Simplex method. Because if feasibility disturbed, remember, okay, student, remember, if feasibility is not be there, then only Dual-Simplex method applicable be, while simplex method does not applicable. The only difference between the Dual-Simplex and the simplex method is simplex method work towards the optimality conditions, optimality solutions from feasible solution B, while the dual simplex method works towards feasible solutions from the optimal solution. Means when you apply the simplex method, feasibility should be there, and then you are trying to approach towards the optimal solution. While in the dual simplex method, you have optimal solution, okay, and you are trying to move to the feasible solution. So this is the basic rule. So when at least one of the element is less than 0, then you are trying to move on the dual simplex. I just explain in the next example someday. Say for example, very simple example is there. Consider that any LPP problem, that is maximization of this, subjective to some constraint are there. What will happen on the solution? Discuss the effect of change the requirement vector 60 40. Here this is 60, this is 40b. Okay, so what will happen is if you change this vector 60 40 to the new vector, that is a 40 20 on the optimal solution. Remember, this is again the optimal solution. Second part is again what will happen if you replace the value 60 40 to the 20 40. And the third one is a more generalized one. What is the range of the b1? B1 is here 60. That is the first right hand side vector of the constraint that consistent with the optimal solution. Okay, so means if here the right hand side is 60, so I just want to replace this 60 with the another number I call as the alpha. So what is the value of the alpha? Can it be greater than of the 60? Can it be greater than of the 100? Can it be less than of the 90? Can it be less? Can it be negative, and so on? Okay, so that is we have to find the range, that is the lower bound and the upper bound of the vector b1, so that the is consistent with the optimal solution, that is optimal solution remain the same. Okay, so while in the first and second part we have to change the vector 60 to the 40, that is a specific one, while in the second is 60 to the 20. Okay, so let's move on this. So firstly you have to find the optimal solution of this, and everybody knows that how to find the optimal solution by using the simplex method. So here this is the problem. Okay, and what will happen is there. Okay, so what is there? So you firstly convert the optimal objective constraint into the equality sign. So how you convert into the equality sign? That is simply by using the slack or the so simply you can replace the less than sign with the slack variable s1 and s2 are there, and then try to solve with the help of the simplex method. That's quite easy, that entering and leaving variables are there, and then you can find the value of the optimal solution is there. So now now the right hand side is 60 and the 40 is there. Now what's the first part said to you is that if you replace this 60 40 to the 40 20, means if you replace this number 60 to the 40 and 40 to the 20, can this 8 and 2 and objective function is 64 be still the optimal solution or not? That's the question arises. So but what is that? Basically what is the three step is, you firstly find the value of the b inverse b. Okay, so the first part is when you replace the value from 60 40 to 20 40 20. So what is the b inverse b? So that is, if you remember how you find the b inverse is, look at this problem. What is the initial table is this, who make I, that is I means identity matrix. So this is the 2 by 2 matrix. Who makes I is, that is s1 and s2. Okay, so here b inverse means that is the column corresponding to s1 and column corresponding to I2 in the optimal solution table. Remember, in the optimal solution, this is so important. So this table is my optimal solution B, and the column corresponding to S1 is this. Okay, and the column corresponding to S2 is this is. So it means the first column is S1. So how you write is B inverse is nothing but that is 1 by 5 minus 1 by 5. Okay, this is a column corresponding to S1, S2. That is column corresponding to S2 minus 1 by 4 and plus 1 by 2. So that is minus 1 by 4 and plus 1 by 2. Okay, so what is the b? So here is, this is my 1 by 5, this is minus 1 by 5, minus 1 by 4, this is 1. So what is the b is? Now you have to change this vector, you want to test this solution b. Okay, so now it's a 2 cross 1, this is 2 cross 1, 2 cross 2 and 2 cross 1, so the matrix will be 2 cross 1. So when you multiply this, that will be 8 minus 5. Okay, and this is minus 8 plus of 10, so this becomes 3 and this becomes 2. Since what is the step third is, since b inverse of b is greater than equal to 0 for all 1, so therefore the current solution, that is the current solution, remains optimal. That is, what is the current optimal solution is this one. Okay, so it means when you replace the right hand side vector 60-40 to 40-20, then the optimal solutions remain unchanged. Okay, so it means instead of the 60 is a 40, 40 is 20, then the optimal solution remains the same. So that's quite easy. Look at the second one. So when the right hand side 60-40 is replaced with the 20-40, so then again you have to calculate the value of the b inverse. So once you calculate the value of the b inverse, you will get a minus 6 and plus 16. So look at that, minus 6 is less than 0. So it means the solution is infeasible. So when the solution is infeasible, you are always apply the dual-simplex method b. Okay, and moreover, when the solution becomes infeasible, it means the current optimal solutions remain optimal solution or not. So what will happen, students? So the current optimal solution does not remain the optimal solution because the feasibility is disturbed. Here feasibility disturbed, so the current optimal solution is not the optimal solution when you replace the right hand side of the constraints with the 20-40. So now you can apply the dual-simplex method. So how do you apply the dual-simplex? That's nothing, that's not a big deal. Okay, so look at that, the final optimal table. This is the final optimal table. Okay, so just copy this table except the right hand side. Here right hand side is 2, 8. Replace this value with the new computed one, that is minus 6 and the plus 16. Look at that, this is the minus 6 and the plus 16. I replace it with the new one. Okay, and then the rest values are same. Now since this table is not the feasible but this is optimal, so you have to apply the dual-simplex method. So what is the dual-simplex is? You have to firstly find the leaving variable. Okay, and in this column find all those values which are negative. Okay, that's only one value, and then it means this is the this is the entering variable are there. If there are the two negative values are there, take the ratio among them and find the maximum in magnitude is there. So what will happen? This is the leaving variable. So x2 is the leaving, s2 is the entering. So this one is there. Okay, so what is that? This becomes the I always. Okay, now then you can simply compute the values of the others. All others are there. This, that is, multiply with the 4 and add them. You can simply compute the values of the all those values. 0 divided by 4, this is minus 4, this, and then half, multiply half, and all that is all elementary row operations are there. And this is 24, this is 4, and the optimal solutions are again, I think 24 is there. So what is that? So from this table, so this is nothing but the zj minus cj. So now what is that? The optimal solution reach. Okay, so what is that? X1 is 4, x2 is 0, and maximum of z is 24. Look at the previous value. The previous value said that x1 is 8. Remember, x1 is 8, x2 is 2, and maximum of z is 64. While now in this case, when you replace the right hand side with the new one, then the optimal solution is not remain the same. Now it will change to the 4, 0, and the optimal values is 26. So this is the impact of the right hand side vector when you replace the value 60-40 to the 20-40. While when you replace the value 60-40 with the 40-20, it remains the unchanged. Optimal solution remains unchanged. Okay, so in order to move on the third part, that is what is the overall range of the B1 or B2 are there. So before just start this part third. I just move on the next example firstly and then come back on this problem is there. So say maximize of this subjected to the three different constants, and you have to find the separate ranges for the b1, b2 and so on. So that's not a big deal. That's what quite so much easy is there. So look at that. You have to find the b1, b2, b3. That is the right hand side. Remember student, whenever you are talking about the right hand side, then there is no need to calculate the zj minus cj, because optimality should be there, always be there. So what is that? What is the step one is you have to calculate the b inverse b. Okay. So what is the b inverse? Here is a 3 cross 3 matrix. Okay. When you start with this is always, you can start with the plus s1. Okay. So I just start with the, if I say minus s2 plus artificial variable is there. Okay. And plus s3 is there. So when you start with the initial table of the simplex method or bigger method, who makes the I is there? That is S1, A2 and S3. That becomes the B inverse. Okay, so that's quite easy. Now it's quite easy. So firstly you have to construct the simplex table, that is optimal simplex table of this problem by using the bigger method or two-phase method, and then from the optimal table you can compute the value of the B inverse. Okay. So look at that. So now objective function is this. If I use the begin method, okay, since the problem is maximization, so I add the minus of the m. So you can enter this, you can leave of this, okay, and so on. So this is the final optimal table, okay, and the optimal solution is this one. Now look at that. What is the B inverse is? Because you want to find the range of the B1, B2 and B3. So what is the B1 is column corresponding to S1, A2 and S3. So what is the column corresponding to S1? Look at that. What is the column corresponding to S1 is this. That is, here is the column corresponding to S1, this is column corresponding to S2, column corresponding to S3. What is the column corresponding to A2 is 0, 0, minus 1. Okay, 0, 0, minus. And the column corresponding to S3 is this one. -1, +1, +4. Okay, so don't be panic that the table is so complex. You can easily solve it quickly. Look at that very carefully. Minus S2 plus A2. The only difference is of the negative sign, S2 and the A2. And look at that, each value is here 0, 1, 0. So multiply with the negative sign, the value is 0, 1, 0. 1 by 4 minus 1 by 4 plus 1 by 4. The negative value of it is minus 1 by 4 plus 1 by 4 minus 1 by 4 and so on. So that is not a big deal. So this is the B inverse. So what is the question is, you have to find the range for the B1. Okay. So what will happen? The initial, look at the statement again. What is the right hand side is initial vector of is 10, 6 and 4. Okay. So now my question is, I want to replace this 10 with some new number, okay, so that the optimal solutions remains this one 0, 4, 0. What are the ranges? Okay, so can I replace 10 to be 8 so that this becomes this? Okay, so is the optimal solution remain same, or can I replace this number with the minus of 3, 4, 3, 6 and 4? The optimal solution remains same or not? So it means we need to find the lower and the upper limits of this B1, B2 and B3. So that is quite simple again. So what is that? After changing B1 to the same new number B1 prime, the new number will be this. Okay. So what is the three-step rule is? Firstly, you calculate the B inverse. We already calculated that. Second is you have to calculate the B inverse P. So here is the B inverse. Now the new number is, instead of this, you can write is as a B1 prime. Okay, so that is that. This is my B inverse, this is my B. If you multiply, the new number becomes this one. Okay, and what is the condition for the feasibility is each number should be greater than or equal to 0. So that is B1 prime minus 4 is greater than 0, so B1 is 4. So that is the range of B1 is 4, infinity. That is, if you want to replace this number, that is on the right hand side, this number 10. Okay, so what we compute is the range will be 4 to infinity. So any number you can choose in between them, the optimal solution remain the same. That is, if I just consider this example, if I case as a -3 or +3, the optimal solution remains the optimal solution changes because 3 does not belong to this interval. Okay, so there is another method also to find the ranges of this by using this way. That is, if we replace the number b1, the original number is 10 plus some increment is there and the rest number are remain same. So what is that? Again, b inverse of b. So you get 6 plus delta times b1 for 2, and for feasibility you get minus of 6. Since this is the value for the change in the b1, and what's the original number is 10, this is the original number of the b. Okay, so if you add them, this is the change in that, that is a 4 again. So the optimal solution remain the same. Similarly, if you calculate the ranges for the b2, okay, so how is that? The given vector is 10 6 4. If you replace with the new vector and you want to find the range for the b2 only, so that this 6 is replaced with the b2 while others are remain same, and then again calculate the b inverse of this and you will get this number. Okay, and for the feasibility, 6 would be already greater than equal to 0, 4 is greater than 0, 16 minus b4 2 is greater than 0, so this is there. So the range of the b2 becomes minus infinity to plus 16. Okay. Similarly, for the b3, you can replace the number 4 with the b3 while the other can remain same, and you get this number. And for the feasibility, 10 minus b3 is greater than 0, second number is greater than 0, third number is greater than 0, and after solving you will get the lower and the upper bound. Definitely a question may arises to the few of students that why b2 is negative minus infinity to plus 16. So it means it can be minus of 7, but when we know that when the right hand side is less than 0, that is minus of 3, minus 4, all are satisfied here, then it becomes infeasible. But we are talking about the feasibility here. The reason is, if you are talking about the minus 3, minus 4 or any number which are lies minus infinity to 0, look at the constraint. What is the b2? Here is the, look at that, this is the greater than sign. So if you take a number as a minus 3 and your task is to make it positive, so multiply with the right hand side and left hand side with the minus, it becomes the less than sign and it becomes the plus 3. That's why, because it's a greater than sign, that's why this is minus infinity. And look at that, this is the lower bound is already less than sign. So if you replace with the minus of 3, then it's again multiply with the minus of something is there. Okay, so hope you can easily calculate them. So very quickly we can move on. The next example is there, that is maximization of this and find the optimal solution. First part, remember in my last video, that is in which effect of the cost vector is there. Here the objective function x1, x2 and x3 all are dependent, and here again x1, x2, x3 are there. It means when you try to solve this problem, there is need to solve with the help of the big M or the two-phase method by using the artificial variable, because here you need to add the artificial variable and here you need to add the s. So what will the b inverse be? If you try to solve this problem with the simplex method or big M simplex method, so who will make the I? That is the first s1 in the here, and if I call as a2 is the second constraint, so a2, this is the column corresponding to s1, this is the a2. So discuss the effect of changing in the optimal solution when right hand side vector 5 2, that is this one number, changes to the 7 2, while 5 2 changes to the 3 9. So you can try yourself, this is an exercise for you. You firstly find the optimal solution. The optimal solution becomes this one. Okay. Second, if you find the b inverse here, then multiply with the 7 2, you will get something. And look at that. From the option you can see that the optimal solution changes. It means for the second part, when you multiply this, okay, it will becomes two number, then at least one of them will be less than 0. Otherwise the solution remains the same. Here they look at that 9 changes to the 11, 8 by 5 changes to 12 by 5. So it means at least one of the numbers should be negative, and then you have to apply the Dual-Simplex method here. Similarly, when you multiply with the, when you replace 5 by 2 to the 3 by 9, then the answer will be here. Okay, again you see that the answers are changed from the original one. So it means again these conditions occurs, will definitely be there. So this is an exercise for you. You can easily calculate them. Look at that. Let the optimal table, this is the optimal table is there, but we are unable to know what is the original LPP. But we know this is the optimal table. That is, the first constraint is less than sign. It means the first constraint, whatever is there, this is less than of something. And the second constraint is f of the equality sign. It means just like this one. And this is the optimal table is there. Okay, so definitely here you are using the slack variable, and here you are using the artificial variable. So that's why there are the two S1 and A2 are there, and it is mentioned that S1 is a slack and the second is the artificial variable. So you have to formulate the LPP. That is quite easy because you already know that how to formulate the LPP. So here the maximization of Z, because it's a problem is for the maximization, there are the three variables. So problem is just something like this way. Your target is to find this one. So there are the two constraints. It is given that plus x3 is less than equal to something plus, so your task this, and each of the xi's are greater than 0. Okay, so what is that? This forms my B. Okay, so what is the B inverse B? Here S1 column corresponding to S1 in the first column and A2 in the second column. So what is the S1 and this is A2? What is the B inverse is? 2 by 5, 1 by 5, minus 1 by 5 and 2 by 5. Okay, so if you find the inverse of this, so how you find the B is inverse of inverse B. So what is the B? B is nothing but this one, that is x2 x1. You get a column of this by taking the inverse of this, so that value of is this one. This is x2 and this value becomes of this one. Okay, and once you know the B inverse, so now you want the B x3 column. So this is x3 column. Okay, so what is the value of this is? So if you multiply this matrix B with this column, that is minus 1 by 5 and 7 by 5, you get a vector that will be here. Okay, similarly this is the right hand side. If you multiply this vector B 8 by 5 and 9 by 5, you will get this vector. What about the right hand side is? So here objective function is already given to you, that is a 5, this is 5, this is 12, this is 4. So this is the way to calculate the first part. That's quite easy. Second part, for each of the discrete parameter changes, make the necessary correction in the optimal table. Remember, this is the it should be the optimal table. So check whether this is optimal table or not. Yes, it is optimal table because 3 is maximization, and for the maximization Zj minus Cj should be greater than equal to 0. So it is again greater than 0. This is greater than 0. This is greater than 0. This is greater than 0. So this is the optimal table. So what will happen is you want to change the value of B to the 310. Okay, so what is there? So firstly you have to calculate the value of B inverse. Okay, so how you calculate the value of the B inverse? How you calculate the value of the B inverse is, so B inverse is nothing but this value. This is my B inverse. Okay, because the column corresponding to this and this. So if you multiply this vector by, how you multiply this vector? By 3 and 10. Okay, so that is B inverse of 3 and 10. Okay, so you get something. Clear? So what you can easily multiply, what is the B inverse of this is? This is 6 by 5 minus 10 by 5. 6 by 5 and minus 10. So this is minus 4 by 5. Okay, and similarly, sorry, 6 by 5 and 10 by 5. 6 and 10 is plus 16 by 5. And if you multiply with 3 by 10 of this and so on. Okay, so once you get all positive, then optimal solutions remain the same, that is 9 by 5 and 8 by 5. Otherwise you can move on that. Second is, so you have to change the C is the right hand side. Remember, when you're talking about the right hand side, so there is no role of the B inverse, that is my Zj minus Cj, because C is my right hand side B. Okay, so what will happen is you can replace this number. Okay, so with that is 4, this is 10, this is 4. Okay, so this is 10, this is 4, and then try to compute the value, because we are talking about the C is my nothing but the Zj minus Cj. Okay, so then we are trying to compute the Zj minus Cj, because this is my vector C, and C is always represent for the Zj minus Cj. So once we are calculating here, this number is 0, 10, 0, 0. This is minus 10 by 5 plus 28 by 5 of minus 4. Okay, so this becomes 18 minus 20 by 5. This is minus 2 by 5 and so on. Okay, so here it's a negative, so it means optimal is not be there, so you can enter this. Okay, and then try to move it until the optimal solutions reach. So this, for more detail about the C, you can see my previous video description, link is given in the description. Okay, so hope you can able to understand. So I just summarized my last 2 videos. That is, whenever you're talking about the right hand side vector on the sensitivity analysis, remember on the sensitivity analysis, then we are talking about the feasibility. And for the feasibility, you are always checking B inverse B, and your target is to move on this. Whenever you are talking about the cost vector C, that is, we are talking about the optimality, and your target is to check Zj minus Cj should be greater than equal to 0 for the maximization problem and less than equal to 0 for the minimization problem. Okay, so there is no role of the B inverse here, there is no role for this, and in the feasibility side there is no role for the Zj minus Cj. So always remember that. So I hope you are able to understand this video regarding the sensitivity analysis on the vector right hand side or the cost vector. Thank you very much. Hope you can enjoy.